Hello and greetings to everyone. We will continue with 7, which is multiples. Most often we make use of the word multiple. Let's take this down. For example, 7 times 10. We know 7 times 10 is equal to 70. And negative 3 times 5 is equal to negative 15. The number 7 and 10, these two numbers are called factors. On the line, factors, factors of 70, while 70 is called I'll write it down with a red pen, because 70 a multiple of the numbers 7 and 10. Similarly, negative 3 and 5, are called factors of negative 15, while negative 15 is a multiple of negative 3 and 5. Now, let's write down the definition of a multiple. A multiple is a whole number that can be divided by another number without any remainder. Now, I'll underline this definition using the red pen. It is very important to take note of this. Now we write this down. Suppose M and N are two numbers such that M, N, they belong to the set of integers. Then I'll write this down with a red pen. M times N, the product, is a multiple of both M and N. For example, negative 10, negative 5, 0, 5, 10, 15, 20 are multiples multiples of the number 5. Now let's note this down. It's very important. Note the number 0. The number 0 is a multiple of every number. Since I write this down with a red pen, since n times 0 is equal to 0 for n belonging to the set of integers, we know if you multiply any number by 0, it gives you 0. So 0 is a multiple of every number. Next, we denote the set of multiples. Multiples of a number n by making use of m of n. This is how we denote the set of multiples of a number n. Now let's note this down. We're going to note certain points here. First point under this, the set of multiples of a number is an infinite set. When we talk of an infinite set, that means it's an endless set. So an infinite set. Next hyphen, there are both positive and negative multiples of a number. You can see like above here, -10, -5, they are multiples of number 5. The next hyphen, if t is a multiple of the number n, then negative t is also a multiple of the number n. We denote this as, I'll use a red pen, plus or minus t. The plus or minus t here simply means positive t is a multiple of n, negative t is also a multiple of n. Now let's take example. Let's write down the multiples of 2. The multiples of 2, we have 0, plus or minus 2, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 10. We have 3 dots. indicating that it is an endless set. And for us to get the multiples, we simply multiply the elements of the set of natural numbers by the given number. Take 2 times 0 is 0, 2 times 1 is 2. We are going to attach the plus or minus sign. 2 times 2 is 4. You attach the plus or minus sign. 2 times 3 is 6. 2 times 4, 8, and so on. So this is the same as, we know the negative multiples will continue to the left hand side. You can start from negative 10, negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8, 10. They will end with the 3 dots. So you will see that negative multiples will continue to the left hand side, while positive multiples will continue to the right hand side. Next, now let's write down the multiples of the number 5. We are going to perform the same thing. 5 times 0 is 0. 5 times 1 is 5. We attach the plus or minus sign. If we multiply 5 by 2, it gives us 10. We attach the plus or minus sign. 5 times 3 gives us 15. We attach the plus or minus sign. Next, 5 times 4 gives us 20. We attach the plus or minus sign. Next, 5 times 5 gives us 25. We attach the plus or minus sign. 5 times 6 gives us 30. We attach the plus or minus sign with 3 dots because it is an endless set. So this will give us, put the 3 dots. We write down negative 30, negative 25, negative 20, negative 15, negative 10, negative 5, 0, 5, 10, 15, 20, 25, 30, then we end with the 3 dots. Now let's take the next setting. Least common, least in bracket lowest common multiple. We abbreviate it as L.C.M. So in L.C.M, it stands for the lowest common multiple or the least common multiple of any given numbers. Let's write this down. The LCM of any given numbers is the lowest common positive multiple of the given numbers. For example, if we are to let's write down the common multiples of 2 and 5. It is denoted as such: m of 2 intersection m of 5 will simply be equal to, the negative multiples which are common. They are endless. They continue to the left hand side. So we are going to write down the multiples we see in this set and we see in this second set. So we can see negative 10, negative 10. Put down negative 10. You can see 0, 0. There is 10, 10. If we continue this set, we are going to meet 20. 20 is a multiple of 2 and 20 is also a multiple of 5. So there's 20. continues to the right hand side. It's an endless set too. Let's write this down. The elements of the set, the elements of the set M 2 intersection M of 5 are called, the elements of this set are called the common multiples, or the common multiples of 2 and 5. I'll underline this using a red pen, or the common multiples of 2 and 5. The common multiples of 2 and 5 is denoted as, I'll write this down with a red pen, M of 2, 5 as such. That is M of 2 and 5 is simply the set. We're going to copy down this set, -10, 0, 10, 20, we end with 3 dots as such. Since it is an endless set, we are going to take note of that. For any two numbers, M and N, we denote the set of common multiples of M and N as, this is how we denote the set of common multiples of M and N. You can see here, in this case M is 2, N is 5, denote it as M of N, M, N. This is how we denote the set of common multiples of any two numbers M and N. The lowest in bracket least common, the lowest common multiple of 2 and 5 is the smallest positive element, of the set M 2 and 5. That is, the smallest positive element of the set of common multiples of 2 and 5 is simply 10. That means 10 is the LCM. Is the LCM of 2 and 5. We note this down. Note the LCM of any given non-zero numbers, any given non-zero numbers can not be equal to 0. Cannot be equal to 0. Then we take a hyphen by the margin. We can calculate the LCM. We can calculate the LCM of any given numbers by using the methods of calculating the HCF, the highest common factor. In this case, instead of taking the products of the common prime factors with the lowest powers, we take the products of the prime factors with the highest powers and also the prime factors that are not common. Example, just find the LCM. Of the following. For A, we have 30 and 40. For B, we have 12, 15 and 36. We take down solution. For question A, we have 30 and 40. We are going to make use of the method of prime factorization. First, let's prime factorize the number 30. Now 30 is the same as 2 times 15, which is equal to 2 times, we know 15 is the same as 3 times 5. Next, let's take 40. We know 40 is the same as 2 times 20, which is the same as 2 times 2 times 10, which is the same as 2 times 2 times 2 times 5, which is the same as 2 raised to the power 1, 2, 3 times 5. So these are the prime factorizations of the numbers 30 and 40. Now we need to find the LCM of the two numbers. The LCM of 30 and 40 is simply equal to, we are going to look at the prime factorization of the two numbers. The prime factors which are common, we have 2, 2, 5, 5. Then we are going to take the prime factors which are common with the highest powers. Here 2 is to the power 3, so we are going to take 2 to the power 3. Here 2 is to the power 1. We are going to take this. The 5s, they are to the power 1, so we are going to take times 5. Then we multiply by the prime factor which is not common with the highest power. Here 3 is to the power 1, so we are going to multiply by 3. This will simply be equal to 2 raised to the power 3 times 3 times 5. This equals 2 times 2 times 2 times 3 times 5. This will simply be equal to, 2 times 2 gives us 4, 4 times 2 gives us 8, 8 times 3 gives us 24, 24 times 5 gives us 120. That means 120 is the LCM of 30 and 40. Next, we move now to question B. For question B, we are going to make use of the second method, which is common division. We have the numbers 12, 15, and 36. We are going to have 4 columns. The first column, we are going to write down the prime factors. The first column we have 12, the second we have 15, the third here we have 36. We can start by making use of a prime factor which is common to the three numbers. We can use 3. 12 divided by 3 gives us 4. 15 divided by 3 gives us 5. 36 divided by 3 gives us 12. Next, we can make use of the prime factor 2. We know 4 divided by 2 gives us 2. We are going to bring down 5 because 2 is not a prime factor of 5. Next, 12 divided by 2 gives us 6. We can make use of 2 again. 2 divided by 2 gives us 1. We bring down 5 because 5 is not a, because 5 cannot be divided by 2. 6 divided by 2 gives us 3. At this level now, we can make use of the prime factor 5. 5 divided by 5 gives us 1. When we arrive 1, it's okay for that column. We bring down 3. Here now we can make use of the factor 3, the prime factor 3. 3 divided by 3 gives us 1. We bring down 1. Now we can find our LCM. You can see under 1, 2, 3, these 3 columns we have 1, 1, 1. So now we can find our LCM. The LCM of the numbers 12, 15, and 36 is simply equal to, you're going to take this product, 3 times 2 times 2 times 5 times 3. This will simply be equal to 180. So 180 is the LCM of 3 numbers 12, 15, and 36. Now let's take exercises for application on this. We take down question 1. Question 1 says write down at least 6 multiples. Write down at least 6 multiples of the following numbers. We have the numbers 3, 4, 7, and 10. Question 2 says find the LCM of the following. Question A, 16 and 18. Question B, 18 and 24. Question C, 21, 40 and 100. Find the LCM of the following index numbers, leaving your answers in index form. For A, we have 2 raised to the power 2 times 3 raised to the power 2 and 2 times 3 raised to the power 2 times 5. For B, we have 3 times 5 times 7, 2 times 3 times 5, and 3 raised to the power 2 times 5 times 7 raised to the power 2. For C, we have 2 raised to the power 4 times 5 raised to the power 3 times 7 raised to the power 2. The second number, we have 2 raised to the power 2 times 3 raised to the power 3 times 5 raised to the power 2, and third number, we have 2 times 3 raised to the power 2 times 7 raised to the power 3 times 11 raised to the power 2. Take down solution. Question 1, we are to write down at least 6 multiples of the following. The first one, we have m of 3. We know m of 3, we have 0, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 12. We know it is an infinite set. So this will give us is endless to the left hand side, negative 12. We have negative 9, negative 6, negative 3, 0, 3, 6, 9, 12, and with 3 dots. The next one, we have to write down the multiples of the number 4. For 4, we have 0, plus or minus 4, plus or minus 8, plus or minus 12, plus or minus 16. You know it is an endless set. So this will be the same as it is endless to the left, We have the negative multiples, negative 16, negative 12, negative 8, negative 4, 0, 4, 8, 12, and lastly 16. We end with 3 dots. Next one, you have the multiples of the number 7. This will give us 0, plus or minus 7, plus or minus 14, plus or minus 21, plus or minus 28. When it 3 dots, this will give us it is endless to the left hand side. We have negative 28, negative 21, negative 14, negative 7, 0, 7, 14, 21, 28. Then we end with 3 dots. We go now to the next one, m of 10. M of 10 will simply be equal to 0, plus or minus 10, plus or minus 20, plus or minus 30, plus or minus 40, plus or minus 50. It's an endless set. So this will give us, we have our 3 dots. We go to negative 50, negative 40, negative 30, negative 20, negative 10, 0, 10, 20, 30, 40, 50. We end with 3 dots. Now we move now to question 2. Question 2 says, find the LCM of the following. For A, we have 16 and 18. For A, we are going to make use of the method of prime factorization. We know 16 is the same as 2 times. Take 2 times 8 gives us 16, which is the same as 2 times 2 times 4. Is the same as 2 times 2 times 2 times 2. So this will simply give us 2 raised to the power 1, 2, 3, 4. Next, if you take the number 18, you know 18 is the same as 2 times 9, which is the same as 2 times 3 times 3. So this will give us 2 times 3 raised to the power 2. Now for us to get the LCM of the numbers 16 and 18, it will simply be equal to, for the prime factors which are common, we have 2, 2. We are going to take 2 with the highest power, which is 4. Then we are going to multiply it by the prime factor, which is not common, with the highest power, by 3 raised to the power 2. So this will simply give us 2 times 2 times 2 times 3 times 3. 2 times 2 times 2. We are going to multiply 2 by itself 4 times. We omitted 2 here. 2 times 2 times 2 times 2. We are going to multiply 3 by itself 2 times 3 times 3. So the LCM will simply be 144. For question B, we have the numbers 18 and 24. In this case, we are going to make use of the method of prime factorization again. We know 18 is equal to 2 times 9, which is equal to 2 times 3 times 3. This will be equal to 2 times 3 raised to the power 2. Now, if you take the next number 24, we know 24 is equal to 2 times 12, which is equal to 2 times 2 times 6, which is equal to 2 times 2 times 2 times 3. So this will give us 2 raised to the power 1, 2, 3 times 3. The LCM of the numbers 18 and 24 is simply equal to the prime factors which are common. We have 2, 2, 3, 3. So we are going to take them with the highest power, 2 raised to the power 3 times 3 raised to the power 2. This will give us 2 times 2 times 2 times 3 times 3. You know, 2 times 2 is 4, 4 times 2 is 8, 8 times 3 gives us 24. 24 times 3 gives us 72. 72 is the LCM. We go now to question C. For question C, we have 24, 40, and 100. We have to find this LCM. In this case, we are going to make use of the method of division. Let's write the numbers. First, we have 24, next 40, and lastly 100. We know a prime factor which is common to these three numbers 2. 24 divided by 2 gives us 12. 40 divided by 2 gives us 20. 100 divided by 2 gives us 50. You can still make use of 2. 12 divided by 2 gives us 6. 20 divided by 2 gives us 10. 50 divided by 2 gives us 25. You can still make use of 2. 6 divided by 2 gives us 3. 10 divided by 2 gives us 5. 25 remains 25. Next, we can make use of 3. 3 divided by 3 gives 1. So we are done for this column. We bring down 5. 25. We can make use of 5. 5 divided by 5, 1. So we are done with this column. 25 divided by 5 gives us 5. We bring down 5 again. 5 divided by 5 gives us 1. We are done now with third column. For us to get now our LCM, the LCM of the numbers 24, 40, and 100 is simply equal to 2 times 2 times 2 times 3 times 5 times 5. So this will simply be equal to, we know 2 times 2 is simply equal to 4. 4 times 2 gives us 8. 8 times 3 gives us 24. 24 times 5 gives us 120. 120 times 5 gives us 600. Therefore, 600 is the LCM of the three numbers. Question 3, it says find the LCM of the following index numbers, leaving your answers in index form. Here we have the numbers 2 raised to the power 2 times 3 raised to the power 2 and 2 times 3 raised to the power 2 times 5. So we need the LCM of 2 raised to the power 2 times 3 raised to the power 2, comma 2 times 3 raised to the power 2 times 5. This will simply be equal to, these two numbers are already in index form. First thing, we are going to write down the prime factors which are common. We are going to take the ones with the highest power. 2, 2 is common. The highest power, 2 to the power 2. Take 2 to the power 2 times 3, 3 they are common, times 3 raised to the power 2. If we multiply by the prime factors which are not common, we have just 5. So this is our LCM. And we have been asked to leave our answer in index form. So we are going to leave the answer as such. For B, this is for A. We go now to B. We have the numbers 3 times 5. We have 3 times 5 times 7 for the first, 2 times 3 times 5 for the second, and 3 raised to the power 2 times 5 times 7 raised to the power 2. So we need the LCM of these three numbers. 3 raised to the power 2 times 5 times 7 raised to the power 2. This will simply be equal to, first thing, we are going to write down the prime factors which are common with the highest powers. The 3 is common. 3 with the highest power is simply 3 raised to the power 2 times the next prime factor which is common. We have 5. The highest power is simply 5 raised to the power 1. Then we multiply by the prime factors which are not common. We have 2, and 2 with the highest power is simply 2 raised to the power 1. Then we multiply by the next prime factor which is not common. We have 7 with the highest power it is simply 7 raised to the power 2. So this will simply be equal to, we are going to arrange the product in such way that the prime factors are in ascending order. That means from the smallest to the biggest. So we have 2 times 3 raised to the power 2 times 5 raised to the power 1 times 7 raised to the power 2. So this is the LCM of the three numbers. We go now to C. For C, we have 2 raised to the power 4 times 5 raised to the power 3 times 7 raised to the power 2 for the first number. For the second number, we have 2 raised to the power 2 times 3 raised to the power 3 times 5 raised to the power 2 for the second number. For the third number, we have 2 times 3 raised to the power 2 times 7 raised to the power 3 times 11 raised to the power 2. So we need the LCM of the three numbers. 2 raised to the power 4 times 5 raised to the power 3 times 7 raised to the power 2. 2 raised to the power 2 times 3 raised to the power 3 times 5 raised to the power 2. 2 times 3 raised to the power 2 times 7 raised to the power 3 times 11 raised to the power 2. So this will simply be equal to, first thing we are going to identify the prime factors which are common in the three numbers. We have 2, 2, 2. We are going to take 2 with the highest power, 2 raised to the power 4. The next prime factor which is common, we have, let's see, 5 is here, 5 is here, 5 is absent here. We go to 3, 3 is absent here, there is 3. We go to 7. So 2 is the only prime factor which is common. So now let's move to 3. We are going to take 3 with the highest power times 3 raised to the power 3. Multiply by the next one, which is 5. We are going to take 5 with the highest power, which is 5 raised to the power 3. We multiply by the next one, which is 7 with the highest power, 7 raised to the power 3. We multiply by the next one, which is 11 raised to the power 2. So this is the LCM of the three numbers. And we are done with the correction of the exercise for application. If in case you have any worries, make sure you leave your questions at the comment section.